Today, I'm going to show you how you can use Hugging Face to start using local models in your computer. Let's get into it. I have my project set up over here. The model that I'm going to be using is the Facebook Ops 1.3 billion. And this is a very small model that's got many years. So the first thing that we need to do is we need to initialize our environment, and I like to utilize UV. So I will say UV init. And as you can see, I get an error because I'm already using UV. And the second thing that I need to do is UV sync, okay? And this, if you don't have the packages in my project, it will install all of the packages required for this. And then the last thing that we need to do, I am on Windows subsystem for Linux, or WSL. So we just need to activate the virtual environment with these commands, and we're ready to go. Okay, now I'll get to explain the code once again. I am using a really small model, like I said, the Facebook Opt 1.3 billion, and then I need to add a tokenizer and a way of loading the model into the backend. The tokenizer is the one that transforms the words into numbers so the system or the computer can understand it. And the model, this this class that I have here, what it allows me to do is to simplify the way of loading the model into the system. And as you can see over here, I have a device map auto, which means that if my GPU is available, what it's going to do is load it automatically there, so it's faster. Now, I've put this over here just for debugging purposes, so I want to print this, so we want to have a prompt that is going to say, once upon a time, my friend had, and because this model is an autocomplete model, so it's not been gone through the post-training phase of preference alignment, what it will do is, it will continue this sentence, and we'll see that in a second. Now, what we need to do with that is the inputs, as I said before, need to go to the tokenizer, so this prompt needs to go to the tokenizer. I want to return the tensors, obviously, in this way, but from the GPU, because it's what we said before here. We want to map it to the GPU. The second thing that we want to do is, obviously, we're going to get some outputs, so those outputs need to be generated based on the inputs, and once that's generated, the tokenizer needs to go and decode the outputs, and in that way we get words back to us again. In a similar fashion, I have another block over here where we're doing the same thing and we're pushing the boundaries of the model a little bit. So over here, I'm just asking it to basically make something up. Over here, based on the model knowledge, I'm hoping that it gives us a concise response around what the relativity theory is. Okay, so what I'm going to do is I'm going to go down here and I'm going to say uv run main.py, and essentially the model is going to start now going through the creation system. Because I already have this model in my computer, I don't need to download it. But if this is the first time you run it and you don't have it in your computer, you will have to go through the download phase. As you can see, once upon a time, my friend had a cat named Bud, and this is what the system is predicted as the next token. It's a prediction model. It's not doing anything else. It's very different from the chatbot models that you are used to seeing. Second thing is, as I expected, the relativity theory of gravity. It's a theory of gravity, and as you can see, it's not doing a very good job because it's a really small model that is based on the idea that the gravity is a force that is exerted on objects by other objects. So that is a simple example of how you can start with the transformers library. But this is not very useful, right? We want to use these for certain applications or certain things that are more entertaining. So I have here another piece of code. This is a little bit more interesting. So I'm using Qwen, because Qwen has got really good models for open source. And I'm going to start with the same thing. The only thing different over here is I'm bringing the torch library, which is the one in which the transformers is based upon. We import in again our two methods, and we create this class. And this is a chatbot class that allows us to use Qwen 2.5, 0.5 billion instruct. So this model has gone through the post-training phase that I said before, and the answers or the way in which we can interact with this model is much more interesting for us for applications because it will follow the conversational approach. Once again, in my class, as I initialize, I need to declare the tokenizer, and then I need to obviously declare the model over here, because this model comes at times you can use them quantized. Most of them, they come in this type of format, so b float 16 or float 16. So in that way, we also can pass the torch type to the system to ensure that the model is loaded efficiently. Now, because I want to recreate a chatbot experience, I'm giving it a history. So this is the conversations that we're carrying out. Now I have my method over here, which is generate the response, which is going to take a user input and a maximum amount of tokens that it can create. And as you can see over here, the messages will have the history plus the new message that is come through, which is the user input. Now to apply this chat template, I need to tokenize it, okay, with the chat template method, and I'm gonna add the messages which the message has the history plus the new message that we've brought into it. The inputs again need to be tokenized, and then they need to go to my GPU, and then all of these IDs need to be generated by the model, and then the response IDs need to be decoded in a second. And once that's done, we want to modify our history so we keep the context of the conversation. After all that is done, we just return the response to the user, and I have a method over here to clear the history if we want. Okay, how do we use this? So I have my chatbot over here. I need to invoke the class, and I call this my own Turing's test, and you'll see why in a second. So the way that models break down words, and specifically the word strawberry, it's normally in 2 tokens. So when I ask how many R's are in the word strawberry, a lot of models get this wrong because it's the way in which the tokens work. Tokens don't work directly word by word. They are broken down in specific sections that at times don't match words at all. I'm gonna just print this string to make sure that we follow along what's happening, and then we'll see what the chatbot tells us in a minute. We're gonna break that down, and then we're gonna ask how many R's in blueberries. We're gonna then get another response, and once that's done, I've created this loop over here, which allows us to keep track of a conversation fluidly based on an input that it's gonna ask me. Let's clear our screen, Control L, and then I'm gonna do UV run when chatbot.py. And as you can see, again, because this model is in my system, I'm not gonna have to download the model at all. And that's why it's going so fast. So how many R's in strawberries? The number of R's, riboflavin, in strawberries is 0.8%. What's happening over here is that these models, they are super small, and the way in which they predict tokens is way more different than any of the larger models. So the larger the amount of tokens that there is in a model, the better it is at following instructions. So over here, it's not understood at all the question that I posed. It's keep telling me a story about riboflavin, if I can say that properly. Strawberries contain vitamin C and da. You can read all of this if you run it yourself. And then I've asked the second question, then how many R's in blueberries? But blueberries contain about 0.3% of their weight in riboflavin. So at least keeping the context over what it thought it should be. And you could expect this because it's the first understanding of the question. Now, let's test if we actually have memory in our system. What did I ask you before? Let's see if it actually thinks. Oh, before answering your question, could you please specify what type of information you're looking for regarding strawberries or blueberries? So it's picking up the conversation because that's what we've designed in the system. Now, this type of chatbot interaction is really interesting when you are obviously offering something to users, your internal employees, or whatever. What we need to be really careful is that we use the right model with the right schema behind it to be able to create useful things. Now, you might be wondering, well, if this is such a small model, why would I want to use it? Like it's giving me garbage, right? Smaller models, because you can fine tune them, you can specialize them exclusively to a task, and they can actually outperform larger models. So if we were to use this model to, for example, create a planning agent, and we wanted to have the planning step going through this model, we could create a super large data set with a lot of instructions around how to break down a task to then create the planning steps on how to solve that task. Really interesting. If you guys want to see how that's done, let me know in the comments below. I'll make sure that I create another tutorial in which I can show you all of this. But hopefully this allows you to get started with Hugging Face, get started with the library, and get you going and start working on your own projects. I'll see you in the next one.